Hello. Welcome everyone to another installment of daily LeetCode live streams where we do LeetCode, we try and get better with the questions, we get closer to our milestones, and we just have an overall good time solving LeetCode questions. Today we're starting at 252 questions, so we're already past the 250 question mark. We're almost about halfway through the easy questions because our target is 600, right? So by the time we get to 300, we'll be halfway there, which is pretty amazing. Honestly, while I did have a lot of faith that I'd make it this far, I didn't think I'd actually get this far. So it's pretty amazing that we're here. I hope that for everyone that has been with me since day zero, you've all learned a ton, you've all had a lot of fun, and you've all learned a lot throughout the whole entire journey. So thank you all to everyone that has been here since day zero. We're going to start today with a very popular question called Roman to integer. I think it's a fantastic question, one that I've already done, but at any rate, we'll just go ahead and give it a shot and we'll go from there. If you've been keeping up with my YouTube, you know that I've recently started a playlist where I have explore card videos. So for some of these questions, like for example, the question we're doing now, Roman to integer, is very popular, like I said, so odds are at some point this will be part of some explore card that will be covered as part of a playlist, which means that if you want more help with a specific question, you're looking for something a little more tailored, then by all means visit these playlists here so you can get more of a deeper dive into any of these questions. So with that being said, let's go ahead and get started and let's see what this question has to offer us. All right, so Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. For example, 2 is written as 2 or II in Roman numeral, just 2 ones added together. 12 is written as XII, which is simply X plus 2. The number 27 is written as so on and so forth. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not I. Instead, the number 4 is written as IV. Because the 1 is before the 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. There are 6 instances where subtraction is used. Okay, so let us see how we can start doing this. So one of the ways I like to do this, and I think one of the ways that I've done it before, is what you can essentially do is you can loop over this entire string, and really what you say is like, okay, if I'm at an I, we add 1, if I'm at an L, V, or like at any single one of these cases, there's always going to be a case for like I, X, and C, and then you can say something like, okay, if I'm currently at an I and my next one is V, then we add 5. If I'm at an I and the next one is X, we add 10. Now, anytime we're at an I and we also have a match like this, we move whatever pointer we're using to go through our array twice forward, right? Because we counted a string that was 2 in length. I'm doing this to really signify I and V, and this to signify I and X. And if we only do I, we only move a pointer once to get to the next character. So that's all dandy and sweet, and it'll certainly work that way, but I want to offer a different way of doing this where we can instead create a map of all the different values, and then all we need to do is we can go through our input array and we can essentially always consider Roman numerals of size 2, and if we have a corresponding match, we just add the value, else we just consider the one right next to it and move forward that way. So let's go through it like this. Oh, big task at hand. Hey, how's it going? Yeah, it's going well. Thank you so much for being here. I remember you from one of my recent streams. Really appreciate you coming back. Hope you've had a great Monday. How's it going with you? Just here starting on some LeetCode and having a good time doing so. Drinking some water, so make sure you guys stay hydrated. Gonna have a sip of water real quick. All right. So let's go ahead and create our object that we're going to use here. I'll call this something like a Roman map, where the key is going to be the different symbols and the values will be the values that we see here. Excuse me. So we have a couple different combinations, right? We have I, V, and X, X, L, and C, and C, M, or C, D, and M, as well as all these different ones here. So I think what I'll do is I'll just go down the line, right? So if we have an I, that's going to be 1. And we should make this a string. Here we can have, let's see, that's I, V, and X. So here we should have I, V is going to make 4, And then we have v, which is 5. We have ix, which is 9. We have x, which is 10. So see, we've done I, v, and x. Right, we have I, v, ix. I'm doing well. Busy day at the office, but I'm good. Glad to hear, man. Glad to hear. Are you all working? I'm guessing you're working back at the office. I'm still working from home since the beginning of the pandemic, but I think we're going to be making a return back to the office starting in October. So a little bit of a bittersweet moment. I think it's going to be team by team basis, so I can't say for sure if we're going to go back, but I've truly enjoyed my time at home because a lot of things have I think gotten better. Like my girlfriend and I live together, so I think that's been pretty good for us. Obviously, sometimes it's good that we spend time apart, but I think that's pretty cool. Also, I've been growing my own like home gym, which I think is very nice, so I can work out sort of like whenever I want, which I think is pretty good. It's important to stay healthy. So yeah. No condom, Chris. Yeah, no, I completely understand. I wonder why for some people like, okay, like no condom, Chris. I'm guessing are you writing from Twitch? Maybe that's why it doesn't show. Yeah, it only shows me. Let me see. Do I have another way of looking at all the multi-stream chat? Yeah, I only see chat from YouTube. So anyway, welcome No Condom Chris. Hope you're having a good time. Hope your day's been good. I think it's the first time I've seen you, so if this is your first time here, I would actually advise for you to subscribe to me on YouTube. I mostly do the Twitch streams so that I can redirect people to YouTube, because on YouTube I have way more content than what I normally have on Twitch. Like I have explore card content, front end content. So if you're into that, make sure to subscribe to me on YouTube. All right, let me go ahead and keep going with this question. So we have I think, you know what, I'm gonna remove these only because it can get confusing. So let's say here we have v that's equal to 5. Fun fact, I'm currently playing Cyberpunk, so anytime I see v, I automatically think of Cyberpunk. Okay, so L, we have 50, C is 100. Sounds like a good time to interview for full remote. Yeah, you know, the company I'm at has been full remote for 2 years, and like my girlfriend's full remote and she really likes it. But the good news is I'm literally right next to the office. Like if there were no trees in my sight, I can probably see the building from here. So it's not too bad. Even if I have to go, it's probably gonna be like a less than 3-minute drive, like honestly. And it could be cool to, you know, it should be fun to like see some people again. So all right, so D is 500, and then we have M sitting at 1000. Let me go over, make sure I have all these again. So 1, 5, 10, 50, 100, 500, and 1000. Then let's go ahead and put the ones that are in the bottom. So IV for 4 and IX for 9. Then we have XL for 40, and we have XC for 90. We have CD for 400 and CM for 900. Okay, cool. So now I think we have all the different things we need. So we have this Roman map now. We have a key to a value where the key is the actual Roman numeral and the value is like the decimal numeral. So what we can do now is we can say let sum. And you know what we could do also? It'd be nice, well, reduce only goes to each one, but I'm gonna need to, yeah, I think what we can do here is we'll have like let index equals 0, let sum equals 0. While index is less than s dot length, what we'll do is we'll get like, should I always try to get a slice of, yeah, I guess we can do that. We can say const, let's say like large slice, I guess, large slice, s dot slice from I to I plus 2. So if Roman map large slice is not equal to undefined, then here we'll say sum plus or equals Roman map of large slice, and we'll also increase our index by 2, else sum plus or equals Roman map of the thing we're currently on. So S of index and index plus or equals 1. And I guess since I'm only using, yeah, no, I should keep it like this. And at the end, we should just be able to return sum here. And that should be enough. Let me go ahead and run this and see what we get. It's been a while, but let's see. Oh, of course. That's what happens when you do so many questions that rely on I, that you just always use I. I has gotten an amazing reputation in the world of computer science. $358 and 1994. All right, let's go ahead and submit this. Let's see what we get. All right, 20.28. I mean, I'm not too concerned about this because I do like this solution. And if I remember correctly, I think it's the better of the two. 28.48, but you know, we should go ahead and read the discussions anyway. It's always good for us to do that and get some more perspective. So clean Python. By the way, for the people that are watching, are most of the viewers wanting to code in JavaScript, or are you just interested to see how someone does things in JavaScript? Because that's actually I guess one of the different ways of looking at my streams is, you know, a lot of people do things in like Python. Python's a very popular language for LeetCode, but you don't see a lot of people doing things in JavaScript. So are most people just interested to see how JavaScript LeetCode is done, or are people also like front-end developers and they use JavaScript and they just want to see how can they do LeetCode with JavaScript? All right, so this is interesting. So translations, S equals S dot replace 4 with 4 and replace IX with V888, or not V888, I don't know why I said that. XL with XXXX, replace XC with LXXX, replace D for car, and S number plus or equals translations car. Oh, did they just make it so that they normalized it so that every single digit represents something? At the end, they're just left with, okay, I guess that's one way of seeing it. I guess I would almost say they kind of like expanded it. So the 4 is equal to 4 ones. A 9 is equal to 1 5 plus 4 1. So each one of these characters taken alone will be found in this map instead of having to also worry about the different combinations. So I think that's pretty cool. Do you code in Python? Because I'm currently learning to code using Python. I don't, unfortunately. I know it's a very popular language, like I was saying earlier, but no, I personally don't code in Python. I've always leaned front end. I'm mostly a web developer at work, so I use JavaScript and TypeScript like all day. I use C# for backend stuff, but I like JavaScript, so sorry. But the good news is there are many very good resources out there for Python, so I know you won't have an issue finding anything else. All right, so we did Roman to integer. Nice way to start. Let's go to monotonic array. All right, an array is monotonic if it is either monotone increasing or monotone decreasing. An array nums is monotone increasing if for all I less than or equal to j. Okay, so 1, 2, 2, 3, so it can never be less. We need to first figure out whether it's increasing or decreasing. So we won't know. I think we should keep going until, I guess this is my plan, right? Let's say we had a number like, once I learn Python, my next language would be JavaScript. Yeah, that sounds great. And I think both of those are very good languages to get started in. I think the most important, there's like two things that I would say that are important. So one of them is definitely like the feedback loop. So if you're coding in languages like C# or C, C++, you're mostly looking at doing like terminal applications, right? There's ways of doing things with like GUIs in those languages, but you're mostly doing things in the terminal, so it's not very fun. But I think if you do something with like Python and JavaScript, especially with JavaScript, I mean, you can show someone to code and you can also show them how to do things in the browser. And I think people seeing things pop up on the browser for the first time is very enticing, because then they start connecting the dots and they're like, oh, this is how, you know, these websites are made, or these are the components that developers use. So it's a great feedback loop to actually see things come up on the screen. And especially with like hot reloading, you can literally just like save a file and the browser refreshes. That's pretty phenomenal. So things like that really help. And I think honestly, the second thing I would say is if you're having fun with the language, like if you like programming in C and you don't care about the feedback loop, then if the fun outweighs what you see, I think that at the end of the day is more important. Some people just really like low-level programming. They have a blast doing C programming. They love working with the terminal. And at the end of the day, just pick the thing that you enjoy working with, because a language is just a means to an end. I mean, I think there'll be a point later on in your career, and I think it takes time to get to this point where, you know, choosing a specific language to do a specific thing is important. That's my take on it, especially if you're dealing with things like scale. You know, certain languages might do things better if you're dealing at a scale that's like, it's pretty crazy, like a scale like Facebook or Amazon, right? But if you're just creating like a hobby project, if you're having fun with it, by all means, just like choose whatever language you want. Yo, Michael SZNG says, yo, what's up? I think you're new. I don't know if I've seen you here before, but that's awesome. Thanks for joining. Hope to see you often. Hope to see you around more often. And how's your day been? Tell us how your day's been. Tell us how your LeetCode progress is coming along. Glad to have you here. All right, so imagine we had something like 1, 1, 1, 2, and 3, right? We're not going to know whether it's like increasing or decreasing until we get to the first number that is different from the previous one. So that's kind of where I want to take my algorithm first. For example, I'll go all the way to 2, and by the time I'm at 2, I know that it's increasing. So then starting from here all the way out, all the numbers have to be increasing. Now this one, let me see. The first thing that's different from the first one. So the 3 is different from the first one, so I know it's increasing, but then we get to the 2 and that's decreasing, and that's false. So let's do this. Let me say, I'll do something like let diff value, or maybe first different value is equal to 0. And then we can say for let I equals to 1, I less than nums.length, I plus plus. We can say if nums of I is not equal to nums of I minus 1, here we'll say first different value is equal to I, and we'll break. All right, so just for what we have so far, let's go over some examples. So we have 1, 2, 2, 3, we have 6, 5, 5, 4, or 6, 5, 4, 4, and then we have 1, 3, and 2. So this first one, like I, right? So for let I equals 1, the reason I choose 1 is in the case that like, well, this would be its own case, right? I think here we could just choose, let's think about this. I think I can make a case for, well, let's actually think about that at the end. So 1 if length is 1, 2 if length is 2. That's like 2 different edge cases I thought about. But imagine these right here. We start at 1. If nums of I is not equal to nums of I minus 1, so our first different value is now 1. Here, the first different value is 5. Here, the first different value is 3. And based on this, we can check to see if it's increasing or decreasing. Here, I can say increasing is equal to false. And let's think about this now. So I can choose this, and I can say increasing equals nums of I is greater than or equal to nums of I minus 1. So increasing is going to be equal to nums of I is greater than or equal to nums of I minus 1. Well, I guess in this case it wouldn't be equal, right? So as long as it's greater than nums of I minus 1. So here, nums of I is greater than nums of I minus 1, so it's increasing. Here, increasing stays as false, and here it's increasing. So now what I think we can do is I can say for let I equal to first different value I less than nums.length I plus plus. Do I want to start at the first different value? So let's see, do we have, how many different cases do we have right now? We can be, if we're increasing, then we want nums of I greater than or equal to nums of I minus 1. That will be true. If nums of I is less than nums of I minus 1, that will be false. If we have decreasing, nums of I is greater than or equal to nums of I minus 1. Now, if it's the same, they said it's okay, right? Because it needs to be, yeah, so it needs to be strict. Array is monotone increasing if for all I less than or equal to j, nums of I is less than or equal to. Okay, so I think we can move, so increasing, and if nums of I is less than, and it's decreasing, okay, false. So if increasing and nums of I, let's see, nums of I is less than nums of I minus 1, return false. Else if not increasing and nums of I is greater than nums of I minus 1, return false, and return true. Let's see if this works. So if it's not increasing, which means decreasing, and if this one is greater, okay, so let's go through each one of these different ones here. So we have I equals 1. Now we have our first different value is at I, which is 1, increasing, and we know it's increasing, right? So now we start here. If true, let's see, so if true, increasing is true, and nums of I is less than nums of I minus 1, which is not the case. Else if not increasing, so that's fine. We can go over here. That's still going to be good. Come over here. If increasing and nums of I is less, no, if not increasing and nums of I return false. Okay, that's fine. Let's come up to here now. 6544. Let me remove this last one here. You get to this. So we picked the first different one for I less than or equal to 1. I think we want to find, because should it be 1, 2? Yeah, I think that could be fine. So we get to 5, which is not equal to the previous one. That's the first different, and increasing is, so no, it's false. So if false, which means this already returns, like nothing happens here, so we go to the next one. Else if true and nums of I is greater, no, that's fine. We get over here, this is not greater, go over here, it's not greater, so we return true. Now for the, I guess the one that's trickier, 1, 3, and 2. So this is increasing. We get to this one here. Now we say if increasing and nums of I is less than nums of I minus 1, we return false. So let's see what this yields. And maybe, you know what, I should have, well, let's see. True, true, false, true, true, false. Let us consider, if I have 1, I feel like a size of 1 should be monotonic, right? It should be increasing. So you come over here, for let I equals 1, nothing happens here. Now, first different value is 0. So since we never made it here, I'm never going to try to find anything that's, yeah, I'm never going to try and find, I'm never going to be able to make it here. So I almost want to say the first different value. Maybe we can say that the first different value is 1, because this has the potential to be, and then here I can say this, for let I equals first different value. That way, in this case, if I have an array of size 1, let's say first different value is 1, for let I equals 1, which means we'll never get there because that's already equal to nums.length. We never go over here, and then again, we never go over here because this is also outside of the length, so then we just return true. Now, if I have something like 1 and 3, right? Let's say I have 1 and 3. So for this one, we start at 1. This would be increasing. I start at 1, and I say if increasing and nums of I is less than, so that still would work. And let me see here, this would be decreasing. So that should still work. If I have 1 and 1, let's see, nums of I is not equal to 1. All right. 1, so we never set. See, this would be a little tricky now. Because if I have a 1 and a 1, I should still get true, right? Because they're all the same. But in this case, I have that my first different value is 1, so I could actually access this one. I'll say it's increasing if nums of I is, maybe I should say greater than or equal to. But then I come here, and if I say if increasing true and nums of I is less than, that's false. If not increasing, so would that still, well, I guess let's just go for it, no? That might be the best thing to do. Like if I have, let's also do 1 and 1, 1. Let's also do like 1, 2, 3, 4 and 4, 3, 2, 1. Like let's do like a lot of perfect cases with some mixture in there. So we have true, true, false, true, 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 false, true, true, true. Okay, so working so far for all the different edge cases. Let's go ahead and submit it, and let's see what we can get. All right, 22.9. Solid. That's awesome. I'm happy about this one. I feel like this is also, I know I say this for a lot of questions, but some streams we do questions that are really good, and other streams we do questions that are really bad. And so far, this stream has been one that all the questions are really good, so I'm very happy about that. So let me check something real quick. All right, we're doing well here. That's 2 for 2 questions so far. Really happy with this one. I feel like we did this one pretty well. It seems like there's maybe a better way of doing it, because if I think about time and space complexity, the time here is linear and the space complexity is constant. So is there a chance that we can do even better? Why do I have a feeling that, can we take advantage of like a binary search by any chance, like a modified binary search? Let's see. An array is monotonic if it is monotone increasing or monotone decreasing. To check whether A is monotone increasing, we'll check AI is less than or equal to AI plus 1. All right. Boolean increasing, Boolean decreasing. So here is looking twice. Okay, we can do one pass. Want to handle a stream of comparisons. Keep track of store equal to the first non-zero comparison. Otherwise, every comparison was necessarily in the set of -1 to 0. Store is 0, int c equals integer of this one if c not equal to 0. This seems a little more complicated. One pass, simple variant. If monotone increasing, if there aren't some adjacent values, and similarly for monotone decreasing, increasing equals false, decreasing equals false. O(n), O of 1. The one pass simple variant is great. I like it. Yeah, I feel like maybe this is the one pass invariant, sort of, where if AI is greater than AI plus 1, increasing is false. If AI is less than AI plus 1, decreasing equals false. Yeah, it's very, very condensed. Definitely a little more clear than this one, but at the end of the day, I'm pretty happy with both of these solutions, and I think the time and space complexity is the same. So in terms of, I guess, readability, maybe this one is better, but I'm happy with this. So let's go ahead and continue. Let's get to day of the week. I think this one has a terrible, yeah, no, we're not even going to bother with this one. Well, let's see what we got here. Day 15, month 8, year 1993. We're not even going to bother with that one. That one, the like to dislike is so terrible. All right. So find resultant array after removing anagrams. So we're given a zero index string array words, where words of I consist of lowercase English letters. In one operation, select any index I such that 0 is less than I is less than words.length and words of I minus 1 and words I are anagrams. And delete words of I from words. Keep performing this operation as long as you can select an index that satisfies the conditions. Okay, so let me see something. One of the ways we can obtain the resultant array is by using the following operations. Since words of 2, BBAA, and words of 1 equals BABA are anagrams, we choose index 2 and delete words 2. Okay. Find resultant array after removing anagrams. So we want to remove all the words that have similar character counts. So like this one has 2 B's and 2 A's. This one also has 2 B's and 2 A's. This one has 2 B's and 2 A's. Oh, I see. But we don't want to remove all of them that have. Ooh, okay. I feel like this one could be really good because it almost reminds me of one that we'll see later, where I feel like we can create an array. This is what I'm thinking about doing. I'm thinking about creating an object literal where the key will represent the frequency of characters, like 2A, 2B, let's say 2A, 2B, and here we'll have like A, B, B, A, B, A, B, A, and B, B, A, A. Here we'll have C, D, so we'll have C, D, and C, D, right? And then all we need to do is just pick one from each. That's what I think is a nice way of doing this question. And if that is the case, this is incredibly similar to a medium style question. And this is exactly why, for anyone that's listening out there, maybe I'm just getting ahead of myself, but this is exactly why I say that there are so many easy questions that go under the rug, because they help set up the foundation for medium questions. And this could be one of them. So let's go ahead and try it out. This is what we're going to do. So we have, let me think about this. We're going to create an object where we have anagram frequencies. Anagram frequencies is an object literal. For const word of words, here we need to create a frequency, and because this is lowercase English letters, I'm going to use a fixed size array to represent all the different characters inside of this word. Then we can do for const c of word, const index equals c dot car code at 0 minus 97, and we can say frequency of index plus or equals 1. Now, we can go through this frequency now and get our key. So let's say something like const key is this empty array. We can go through, and let me think about this. I think now I might need to get, I should use a for let I, yeah. For let I equals 0, I less than frequency dot length, I plus plus. Here what we can do is say if frequency of I is greater than 0, then we should say key dot push. This is going to be like a key that looks like this. If I want 2A, what I need to push in here is frequency of I, which is the frequency, and then the character will be string from car code I plus 97. Now, if this looks crazy to you, I will explain this once we're done here. So key dot push, and then finally inside of anagram frequencies, I can say if, let's say, const joined key equals key dot join, if anagram frequencies of joined key is equal to undefined, so there's nothing in there yet, we'll set anagram frequencies at joined key to equal an empty array, and then we'll set anagram frequencies of joined key dot push. In here, we're going to push the word. And then all we need to do at the end, so now we can say const result is equal to an empty array. Now what I can do is go through all the entries inside of anagram frequencies. We can do that by saying for const, let's see, key words of object dot entries of anagram frequencies. Let's see, so I guess we just want to push for const key and words of object entries anagram frequencies. We should be able to do result.push words of 0, return result. I know I realize I wrote that really quickly, but just bear with me. I'm very curious to see what this ends up giving us, because if this is the right answer like we see so far it is, I'm telling you this is just exactly like a medium question. This one, so the answer here should be all of them, right? A, B, C, D, E, right? A, B, C, D, E. I'm going to submit this. I feel good about this. Oh, man. Okay. A, B, A. Oh, you know, we were so close, guys. We were so close. I really feel like we were onto something there. Really felt like we were onto something. A, B, A, A, B. So what is the words I consists of lower English letters? In one operation, select any index I such that 0 is less than I is less than word's length, and words of I minus 1 and words of I are anagrams, and delete words of I from words. Okay. Oh, and it only needs to be in one operation, select any index I such that 0 is less than words dot length and words. Wait, in one operation, select any index I such that 0 is less than I, less than words dot length, and words of I minus 1 and words of I are anagrams. So they need to be next to each other. That's the piece that we completely missed, isn't it? Because here, like, these are next to each other. Okay. Now, if we have, let's think about this. Could we use something similar to this? One of the two ways we can obtain the resultant array is by using the following operation. Since words of 2 is BBAA, we choose index 2 and delete words 2. Now words equals ABB, BA, okay. Since words of 1, BA, BA, and words 0. So maybe what we can do, choose index 1 and delete words 1. Now words is AB, AB. Oh, so they need to be next to each other. That's the piece that we missed. Well, by the way, I just gave you all an exact pattern to figure out a medium question. I forgot the name. I think the name is called group anagrams, where you take all the words that have similar character counts and you stick them inside of an array. And this is literally what it is. Like, I thought this would work out well for us for this one, but it's not, because I'm not only considering words that are next to each other. So the submission was what we had, A, B, and A. So none of these are next to each other. What if I had a map? What if we had a map of all the anagrams that are next to each other? Do we only push? I guess maybe we can also do that, right? Like ABA, we can say this is an anagram, but this is at index 0. B is an anagram at 1. So here we'd have like 0 and 2, so we push all those together. Maybe we can still kind of retain this same thing. But for each word, let me see. We only pick 1. What do I mean by that? So yeah, I think what we can do here, okay, hear me out. This is gonna seem a little bit strange, but we can say for let I equals 0, I less than words dot length, I plus or equals 2, 0 and 2, because that means that they're at least 2 positions away from each other in the original array. They're not next to each other. But that still doesn't take into account, I mean, we certainly can try it out. We can say result dot push words of I. I'm very curious to see if I, nope, don't want to read discussions. Sometimes that happens to me. Let's do example test cases and let's add our new one in here. This might work, but ABBA, ABCD, and ABA, so actually ended up doing worse. Because this doesn't consider shown words after performing all operations. It can be shown that selecting the indices for each operation in any arbitrary order will lead to the same result. Because in my head, it seemed like we should only ever choose one from the group as long as the indices are not next from each other. Like we choose, so all these have the same key, right? 2A, 2B, but only choose one of these since all the indices are next to each other. Whereas for this, I keep clicking the wrong thing. For this one, this has the key of 1A. This also has the key of 1A, but their indices are 2 apart, which means that we can select both of them. So I almost felt like, let me see. Yeah, we need a way to keep track. We need a way to keep track of the index as well. And I mean, what I could do perhaps, what if we also added, like I could do something like, does this, oh, but now this isn't going to give me the index. For const words of words, for const C of word. Let's see something. For let I equals 0, I less than words dot length, I plus plus, const word is equal to words of I, just so that way I don't have to change anything else. But then down here, we can push word, and we can also push index. And then what I can do here is I can do I less than 0, I less than words dot length, I plus plus. Let's think about this. If they're next to each other, yeah, that'll get tricky. Because like the algorithm here should be now only select, like if they're all next to each other, only select one from the group. But I can always select it if it's not next to another one. Okay, how about this? We can do result.push words of 0. We can always push the first one. And then we start at 1. And then from 1, we can say if, let's see, if they're right next to each other, that means the index difference will be, because if index 3 is next to 2, it'll be 1. If like 10 is next to 9, that'll be 1. So we could say that if, this is gonna be interesting here. If words of I dot index minus words of I minus 1 dot index, if that's greater than 1, then we can also add this result.push words of I, because that means that they are greater than 2 apart. Now, I feel like I may be thinking about this in a too greedy of a way. I'm just saying, yeah, because I think the point of the question here is we're doing operations in the meantime, and we're sort of compressing the array as we go along. But let's see what we get here. This is a little bit convoluted for an easy question, I think. And here we only want to push .word and .word. So let's see this. Okay, so it worked for that one. And then ABAB or ABA. Let's make sure to remove this last piece. Output is AAB and ABA. Does the output need to be shown that various operations will lead to the same result? And so do I need to no 2 adjacent strings and words are anagrams of each other? Is it, I guess the output needs to be exactly the same, right? Will lead to the same result. Okay, so there's got to be a different way of doing this. I'm still happy that I went through the motion of going through all this code, because it's good to practice some of these other parts of JavaScript I haven't used in a while, like object entries. I think that's pretty neat. And just also thinking about this question like I did for the medium one, the group anagrams one is cool too. Is there a better way to do this though? Well, not a better way. Is there another way of doing this? Because I haven't even figured out a way of doing it. These can be in any position. I mean, can we just go through the array? Like, what if we just go from left to right and we just look at the previous one? Like, okay, like I'll add the first one. I compare the frequency count of this one to the previous frequency key. They're both the same. I compare this one to that, they're the same. This one to that one, they're the same. Or rather, when they're different, I add it. I start with B, they're different, I add B, they're different, I add A. So maybe that can work too. What I'm thinking, I'm just gonna like reset this whole thing. Imagine we still kept that notion of like having a frequency key. We always add the first one, and now we start at the second one. So we set the current key to be equal to this frequency. We generate a new key, and then we compare them. If the keys are both the same, we don't add them. Here, the keys are both the same, so we don't add them. Here, the key will be different, so we do add it, and we set the previous key equal to the new key, right? So that could be a way of doing it too. So let's go and do, let's see, const results equals an empty array for const word, or actually we're gonna initialize this with words of 0. Here I'll say for let I equals 1, I less than words.length, I plus plus. And that's also, we need to generate a key for that word, right? So I'm gonna create a function for this, and I'll say generate key, and this is going to take a word, and this is going to, let's see, so we have const key for const c of word. Yeah, there's a lot of things we need to do here, right? We need to get a word, need to generate the frequency, so there's a lot of stuff we need to do here. Const frequency is a new array of size 26. We're going to fill this up with 0. For const c of word, const index equals c dot car code at 0 minus 97. So we can normalize lowercase a, b values, so on and so forth. We'll say the frequency of index is plus or equals to 1. That's const frequency. Now we'll have const key for let I equals 0, I less than frequency.length I plus plus. If frequency of I is greater than 0, then here we'll say key.push of, we want what? We want the letter. So frequency of I, and we want the string. String dot from car code I plus 97. Close this off, close that off, and then we return key dot join. All right. So const result is this. We'll say let previous key equals generate key of words of 0. All right, so now we can say const current key equals generate key of words of I. If current key is not equal to previous key, that's when we'll do something. Else we just always set the, let's see, the previous key equals the current key. So if current key is not equal to previous key, then to our result, we can push words of I. And then we return result. Let's try this out. A, B, B, A, C, D. We have A, B, A, and A, B, A. Okay, nice, very nice. So that worked. Let's see if this will work. Okay. Let's go! Yo, that was sick. Okay, I feel awesome about this question, man. I mean, this is like, wow. Very, very cool question. Very curious about, I want to try this time complexity thing out here because this, let's see, generate key, let's think about time complexity, right? This is static, this is fine. For const C of word, which will always change, this is variable. This is going to be linear here, and this is going to be n plus 26. So let's say this is going to be O of W for time complexity, where W is the length of the word. And then for space complexity, we'll have to create a key, and that's going to take some amount of space. The key will be however many letters there are in that string, but not letters, however many unique characters there are in that string, because we'll need a slot. Key.join will be as large as there are, like if there, let's see. Yeah, if there's like an A and a B, even if there's 5 A's and 10 B's, key will only have 2 indices, right? So it's like the amount of unique characters inside of our string. So in previous key in here, words.length, this will be n times, to me it's almost like a quadratic. It's an n squared essentially, because we're doing n to go through all the different words. For each one we're generating a key, which is going to be n times w. Space complexity here, it seems like it's probably trending towards the size. I mean, it's some, how do I say this? It's some amount of the input, if that makes any sense. It's not exactly linear, but it's also not constant. So let me submit this again and see if we get something different. Are we trending? So this is 50, not too bad. Let's do this one. 49.10, so on the way downwards. I would like for it to go higher, but I'm very interested about reading the, oh wow, just been on a steady decline, and I was feeling really good about this one. I mean, there might be, let me think about this. It'd be nice if we don't have to calculate the frequency every single time, because that's definitely taking a hit, right? For each one of these, we're calculating a frequency every single time. I mean, we could check like these are both the same. So I could do something like if the words are the same, that might give us a slight optimization. But yeah, if current key is not equal to previous key, we could do something like if words of I is not equal to words of I minus 1, and, right? That way, in cases like this, CD and CD, we don't have to generate the key again. Like, we know it's going to be the same, right? So const current key, we're going to generate the key. These are not the same. We generate a new key, and then we come over here, const of, oh no, wait, if const current key, yeah, no, wait, that's not what I meant to say. Actually is const current key, let's see, we can say, maybe we should say let current key equal an empty string. Here we say if words yeah, you know what? Maybe for the sake of the question, it's gonna be a very slight optimization. The code might just look worse, but let's see what discussions have to say here. Weird descriptions. 2 pointers without sorting. Okay. For every we will put our first pointer at a string and second pointer at the next position. Keep on moving the second pointer by 1 step ahead if the string it is pointing is an anagram of string at first pointer. Function to check if 2 strings are anagrams or not. Yeah, I guess we can also just, I guess that's also another way. It's about the same thing though, but we're creating, let's see, n, oh yeah, look, n times m and space is 1. So I was right about the space at the time. Perhaps this space complexity, it's better because we're not creating keys. However, here, auto IP count, oh, I guess this is, yeah, they're just using the frequency. Okay, I see, which is going to be constant anyways. Weird description. Misread this question 2 times and wasted like 20 minutes. Wanted to bubble up this solution by one of our humble commenters below, whose name rhymes with Batman. Apparently, itertools group by groups consecutive elements by a key, and next takes the first element from that group. This is I mean, very cool code. I think this is probably, I feel like maybe this person is a competitive programmer, because some of these questions, I mean, some of these answers are hard to read, right? Hope I'm not the only one that feels like that. But anyway, I think we had a phenomenal stream today. I feel like this is a very high quality stream. I learned a lot, and I think we covered very good ground here. So this honestly is one of my top streams I feel like I've done. So I'm very happy about that. Very happy that everyone was able to join. We got some nice interaction in the comments. So if you like this, make sure to follow me on Twitch, subscribe to me on YouTube. YouTube is where I put all of my main content. It's where I have things like, of course, my YouTube live streams. Let me go ahead and open this here. Obviously, I like working out, and I also like Mr. Matty Plays. I like Xbox stuff, so don't laugh at my recommended page here. So I like things like LeetCode, obviously. I put a lot of stuff with all the LeetCode streams we've done. I have explore cards for the one I'm currently working on right now, the LeetCode Beginner's Guide. So if you're into that, make sure to follow and subscribe. I have the weekly roundups that we do at the end of every week on Sundays. And I also have With Vanilla, which is another series about vanilla JavaScript projects. So if any of that stuff interests you, if you like what you see, if you like talking about code, if you just want to hang back and listen to me ramble about LeetCode, this is the place for you. Thanks again to everyone that joined, and I hope to see you all tomorrow. Hope you have a great rest of your Monday.